everyone. Until now, we have finished the first subsection of this chapter, and now we have continued to the next subsection. This subsection is about the introduction to KVM. Actually, Huawei's Fusion Compute applies KVM as a fundamental architecture. So, in this course, you should work extremely hard.
Next, we will talk about KVM. And what is KVM? Why do we want to talk about KVM? We need to understand KVM because Huawei's latest version of server virtualization products is based on KVM architecture. KVM is called kernel-based virtual machine. It is a typical Type 2 full virtualization product. It is called a kernel-based virtual machine because KVM itself is a Linux kernel module. When a physical machine with a Linux operating system is installed with this module, it becomes a hypervisor. At the same time, it will not affect other applications that were originally running on Linux. Moreover, each of its virtual machines is a process. We can use Qlink directly in the Linux interface. And then, this process is queued. After a normal Linux installation of the KMV module, 3 operating modes will be added. The 3 buttons are drawn on this picture. The first one is the guest mode. This mode mainly refers to the virtual machine, including the virtual machine CPU, memory, disk, and so on. This mode is placed in a restricted CPU mode. Then, the second button, user mode, is also user space. This mode is mainly running QEMU. It is also used to simulate the execution of the I/O class operating request for the virtual machine. Finally, there is a kernel mode, which is the memory space. In this mode, it is possible to actually perform hardware operations. When the guest OS performs an I/O class operation or the privileged instruction operation we mentioned earlier, it needs to submit a request to this user mode, and then it is initialized again by the user mode. This hardware operation is sent to the kernel mode to perform the real operating hardware. The KVM system generally consists of 3 parts. The top is management tool. This is a good tool to manage virtual machines and manage these hardware resources. KVM had a lot of management tools including Virt, Virt Manager, Virt Viewer, Virt Install, and some other third-party development tools. Among them, Virt and Virt Install are command line. That is, we directly click the command to operate. Then, Virt Manager and Virt Viewer are graphical interface. There is also the kernel module of KVM, which are the core components of the entire KVM system. It can be combined to form a complete virtualized solution. The KVM kernel module is a core part of the KVM virtual machine. As we said earlier, the Israeli company developed several major products which were actually KVM modules. Its main function is to initialize the CPU hardware past the virtualization mode, and then run the guest machine in this virtual machine mode, providing some support for the virtual client's operation. It does not have any analog features in its own right. It just provides an interface. This interface can be used by the host to responsible for the creation of the vCPU. The allocation of address space of the virtual memory, the reading and writing of the register of the vCPU, and the operation of the vCPU. It provides this interface and then lets the host to do these operations. Therefore, the interface actually only provides virtualization of CPU and memory, according to what we mentioned earlier. In addition to memory virtualization and CPU virtualization, virtualization still needs some other things, such as network cards, hardware, and so on. At this time, it needs another component, which is QEMU. QEMU itself is not a part of KVM. It's a generic and open source simulator and use pure software to virtualize. The virtual machines think that it is dealing with the hardware. In fact, it rarely deals with QEMU. The QEMU also will deal with the hardware. This means that all hardware interactions need to go through QEMU. Therefore, the performance of simulation using QEMU is relatively poor. QEMU itself is an analog function with CPU and memory virtualization, but in the KVM system, the KVM module virtualizes the CPU and memory, so QEMU no longer does this. It is mainly used to simulate I/O devices. KVM developers have modified QEMU to form the QEMU KVM module. In QEMU KVM module, KVM runs inside and outside space, and then QEMU runs in user space. When the guest OS issues an instruction, all the CPU memory-related instructions will call the interface provided by KVM module through an interface in the QEMU KVM module, so that this part of the instructions can be handed over to the kernel module for processing. Then, from the perspective of QEMU, this can improve virtualization acceleration. Other I/O operations are all implemented by QEMU part of QEMU KVM. So, KVM plus QEMU will form a complete application virtualization. To sum up, the KVM architecture is divided into 3 parts, and the management tools are not mentioned. Then, the KVM module is used for CPU virtualization and memory virtualization. And then, QEMU is used to simulate other I/O devices such as network cards, hard disks, and so on. That is, QEMU is used for I/O virtualization. QEMU plus the KVM is a complete virtualization solution. Coupled with management tools that are easy for others to manage, a more complete virtualization solution is formed. In fact, a more virtualization solution follows this architecture. For example, Huawei's Fusion Compute. Its management tool is VRM, and its virtual part, which is equivalent to KVM and QEMU. It is called CNA. Everyone can be familiar with this architecture, and you can use this architecture to grasp the architecture of other virtualization vendors. On the previous page, we also saw a tool on the photo, libvirt. What is libvirt? It is an open source project. It is a very powerful management tool. The management virtualization platform can be KVM, it can be NAND, and it can be VirtViewer and Hyper-V and so on. Why to use it? KVM itself is an open source project. Many people will do some development based on KVM and then develop the management tool for their own. These management tools may be developed by Java, developed by Python, or developed by other languages. But KVM itself does not support so many languages for management virtualization. What to do so? There is a libvirt, which can directly manage KVM, and then it also provides an interface to each languages. So, no matter which languages you use, you first get to the libvirt and then manage KVM through libvirt. This is what libvirt does.
Okay, everyone. In this course, we have learned some basic information of KVM. If you have listened carefully, you must have an impression of this word, QEMU. QEMU is a simulation tool to deal with virtual machines' I/O requests, but its performance is bad. In next course, we will talk about why its performance is bad and what technology we will use to improve its performance. and see you in next course. Bye!